Welcome to the polynomial long division lesson. The first problem we have here is 2x to the third plus 5x squared minus 3x plus 7 divided by x plus 2. And so what we want to do is we want to distinguish between the dividend and the divisor. So let's do the divisor. So that's going to be x plus 2 divided by the dividend. So the dividend is going to be 2x to the third. And you have to be careful, but there aren't any placeholders that are needed because all of the values are settled in. So 2x squared, 2x to the third, plus 4x squared. You want to be able to match the first term and be able to distribute that negative so that you can actually cancel the first term. So you're left with x squared minus 3x, and you bring down that next term just like in long division. So plus x, so x squared plus 2x, you want to distribute that negative. So then that would get you to negative 5x. You bring down the 7, you go minus 5, minus 5x, and then minus 10. If you were to distribute that negative, you would get 0 for x's, but you get 17 as a remainder, so that the things that are remaining are your remainder. So bring down the quotient, which would be your answer, but also you want to then add on to that by using your remainder, 17 over the divisor, which is x plus 2. So this next problem we have is 3x to the fourth minus 5x cubed plus 2x squared minus 4x plus 8 divided by x squared minus 3x plus 1. So in this problem, we don't see anything that's wrong about it. There's no placeholders that are needed, so we can just go straight into a divisor and a dividend. So the divisor would be x squared minus 3x plus 1. And then we also have our dividend, so that would be 3x to the fourth minus 5x to the third plus 2x squared minus 4x plus 8. So we would try to match that first term, and so 3x squared, so it gets you to 3x to the fourth minus 9x to the third. And we have to be careful, we can't stop, we still have another one, so plus 3x squared, and so we distribute that negative, we get 0, and now we also get 4x to the third, and we get minus x squared, and so we would bring down another term to match our three terms in the divisor, so plus 4x, so 4x to the third minus 12x to the second, and then plus 4x. You want to be able to match that first term. That's the most important one. So now that would be 0, and then that next one would be 11x squared. And then following that would be minus 8x plus 8. So we bring down that 8, and we have one last thing to do, plus 11. So in this case, it would be 11x squared minus 33x plus 11. And if we were to distribute that negative, we would get 25x and we would also get minus 3. So that would just be our dividend. Oh no, sorry, our remainder. So our remainder is 25x minus 3. And our quotient is 3x squared plus 4x plus 11. So our answer is our quotient plus our remainder our remainder is x squared minus 3x plus 1, so that's our divisor. We have to make sure that our remainder is over our divisor. So our next problem is going to be, again, it seems to be like a pretty clean problem. There aren't going to be any placeholders that are necessary. And placeholders, you would have to use a 0. So say you were missing an x squared in this case, you would have to set that to 0x squared. So since that isn't an issue, we can just simply solve another problem. So pause the video and try this on your own. X minus 2. And so it's pretty self-explanatory. There's nothing extremely difficult about this. Mistakes that students most commonly make is honestly just matching that first term and just going too quickly. Especially when you're going fast, you make these careless mistakes. It's not so much that students don't know how to do it. It's more about just not making careless mistakes. So, again, make sure that negative gets you a positive. So 3x minus 6. Notice how my numbers are always working. A common pattern that you could definitely use would be to sort of see, does my first term always work out? And if it doesn't, then something might be wrong unless you obviously have that remainder. So appreciate you watching this video, and I'll see you in the next one.